Hey class, so like I promised, I was going to pre-record this lecture because I'd be traveling. So we're moving into data visualization. So I hope to start out you understand that we've been learning about statistics, probability, pivot tables, data literacy, like how do you understand data, how do you think critically about that data, how do we define the problem. We've been focused on question answering, so we did question answering with pivot tables, we did question answering with SQL. So we're developing this question and we want to provide a good answer to it, an answer that we've thought critically about and that actually is relevant to the question. So data visualization is just another tool in our toolbox, and in fact it's a very powerful tool. So if you take a look at this, let's just talk about why we'd even care about data visualizations. So you might ask, well, why should I use them? Well, let me try to illustrate why you might use them. So if I give you like 15 seconds, 30 seconds, I said, tell me how many 7s are in this matrix. Go. I saw 4. Do you see 4? Did I miss any? So, see, with a small data set, we could probably do it. But what if I said, okay, tell me how many 7s are in this matrix? 30 seconds. Go. See, I even gave you a full 30 seconds there, or at least close, more so than the last time. Did you find them all? You see, our minds aren't very good at keeping track of stuff, and it would sure help if we can make things pop. And so, in the simplest form of data visualization, let's say there were 10 7s. Did you see all the 10 7s? But what if we did this? What if we just simply used like conditional formatting and we highlighted them? Do you see how it makes things pop in our mind? Our visual sense can actually be leveraged to get information out of this matrix, to answer a question. And that's a very simple question. But that's the power of data visualization, is we're just visual people. We're visual creatures. There's information that we can communicate visually better than in tables or verbally. And so that's the power of data visualization. Perhaps we could learn from a genius. Einstein once said, if you can't explain it simply, you don't understand it well enough. And I just think that's the essence of visualization. If you can't put it in a visualization where you tell a story in a very simple manner, but yet that story is very rich. Think of his equation, E equals mc squared. Very simple equation that he's famous for, but it captured something that scientists had been eluding scientists for years. So he captured something very complex in a very simple formula. And that's the analogy of what we want to do with data visualization. And so when you get ready to do your partner project, you're going to be doing data visualizations. And I'm just going to give you a warning here and now that if you throw together any old viz, if you open up Tableau, you import the data, you spend about, say, even a night, oh, let's just put some stuff together, you're not going to score well on that assignment, and it's worth a lot of your grade. So remember, this is about swimming in the data. This is about exploring the data. This is about getting to know the data so that you know the story that it tells, and you can identify an interesting question that you can answer very well with a visualization. So it's kind of like this balance. On one hand, you don't want your visualization to be trivial and uninteresting. It can't be too simple. On the flip side, you don't want it so complex that we can't see the story in the visualization. And so you want to have this visualization that is very simple but tells a complex story. And it's not an easy skill to gain, and it takes practice. So I guess the takeaway from Einstein here is be prepared to spend a lot of time getting to know your data so that you can explain it simply enough. It's kind of a paradox. Like, it takes more work to present something that's simple than it does to present something that's complex. Because the complexity sometimes indicates that we don't understand it well enough. So keep that in mind. So there's this man, and I think he's like more famous than he should be. I've looked at his books. They just don't speak to me. But he does have a couple good quotes. Edward Tuff says, "Graphics reveal data." So think about that. That's another thing to think about. That's what we're trying to do. We're trying to take the data and reveal the story, the information, visually through graphics. There's a great book that I think is available in the library, and if I remember right, I've linked it on Blackboard. And she's almost like, I used to work for this company called National Instruments, and we had this saying, "Eat your own dog food." And I think what it meant was, if you're a dog food manufacturer, maybe you should try eating your own dog food just to make sure it's high quality. So use what you're producing. So she actually fits this saying because her book is very simple and very easy to flip through and understand what she's trying to say. So it's a very quick read. So I would highly recommend you read the chapters that I've outlined. So she says, while tables interact with our verbal system, graphs interact with our visual system, which is faster at processing information. This means that a well-designed graph will typically get the information across more quickly than a well-designed table. Words of wisdom. And Edward Tuff talks about creating a picture of these numbers. He says, often the most effective way to describe, explore, and summarize a set of numbers, even a very large set, is to look at pictures of those numbers. So that's really just what we're trying to do. So there was this guy named Anscombe. He was a famous statistician, and back in the day, he had this frustrating debate with his colleagues. His colleagues were like, all we need is some simple descriptive statistics. So let's take a look here. Let me pull up my pen. If you take a look at these numbers on the right-hand side, those are all descriptive statistics. Now, the interesting thing is if I took the mean of all these x's, interestingly, got a wire in the way here. Interestingly, the mean of all the x's ends up being 9. If I take the mean of all the y's, they end up being 7.5. So all these y's have the same mean. And we could go on and on with all these descriptive statistics. All these descriptive statistics are the same for each of these 4 sets of data. So Anscombe, he manufactured these sets of data so that they'd all have the same descriptive statistics. And so why he did this, he was trying to illustrate that when we then visualize these data sets, they have very different stories. Take a look at data set number 1. Imagine these were stocks. Okay, and along the x-axis we have time. And along the y-axis we have price. And imagine these were 4 different stocks and we were trying to make a decision on which ones to invest in. Well, if we took a look at all our descriptive statistics, we couldn't distinguish between them, right? But if we take a look at stock number 1, you see it kind of got this nice up and to the left trend. So would we want to invest in this stock? You know, our prices are kind of random. But in general, we see this nice up and to the right trend. Sorry, I said up and to the left. And that's kind of what investors are looking for. We want the stock price to increase over time. See, that tells a very good story of a stock. You know, and if we imagine that our investing point's at this last point, we'd ask the question, should we invest in the stock at this point? Well, yeah, probably. If history is a predictor of the future, yeah, we probably want to. On the other hand, when we take a look at stock 2, think about the difference in the story that it tells. And right here, knowing the past, should we invest in the stock at this point? Well, I mean, there's obviously more to the story than just what we're seeing here. But if we're just talking about the historical trend, it kind of looks like it's on the decrease. So we're probably not going to invest at that point. You see, those two tell 2 very different stories, stock 1 and stock 2. Now what about stock 3? Should we invest? You see how it's a very different story? It is, it's a very different story. Even though we had this like quick blurb, we kind of came back to this trend here. And so at that point, you know, we still kind of have this nice risk-free upward trend. There's no variation. So compared to stock 1, stock 3 seems fairly low risk because it's pretty predictable. We got this nice straight line. Now let's get to stock 4. Now what are your thoughts about stock 4? Hopefully you're thinking, man, who hired their accountants? Right? Like, this doesn't even make sense. Like, how can the stock price fluctuate that much if this is a given day, right? Like, what happened to all these stock prices? Did we not sell stock in between? I mean, we should be scratching our head and be like, I'm not even going to touch that with a 12-foot pole because that doesn't even tell a valid story, right? So these visualizations actually presented something that these descriptive statistics did not. And that's really important. That's why we do visualizations. So now you know why we actually are interested in visualizations. And in fact, I will just say accounting employers are always asking us to teach students how to tell stories with data. They want a skill of storytelling. And we're just going to scratch the surface here, but storytelling really amounts to, I create this interesting viz, there's something that catches my attention, but then I hone in on a specific part of that viz and be like, it makes me kind of scratch my head and say, I wonder what's going on there. And so I dig deeper and I generate another viz or 2 or 3 to try to explain what's going on in that specific area of my first viz. It's almost like the scientific method. You find some phenomenon that you're like, whoa, that's interesting. And so you make a hypothesis. And then you generate a visualization to prove or disprove that hypothesis. And if your viz kind of disproves the hypothesis, then you make another hypothesis. And you generate a viz or 2 or 3 to prove or disprove that hypothesis. And so it's kind of this story that you're telling, well, this phenomenon could be because of this, this, or this. Let me take you on a journey to find out which one of those is true. And you're generating different graphs to prove or disprove those hypotheses. That's what we mean by storytelling. Now, storytelling usually amounts to multiple vises, but you can put a whole story into one viz. And so what I want to focus on now are specific principles to create a single viz in an aesthetically pleasing manner. And these all come from Nicole Knopflich's book, the one that I referred to that's really easy to read. And so the library has her book online and you can read it. But I pulled some examples from her book that I thought were especially interesting. So after you've spent this ginormous amount of time exploring your data, creating different vises, not really being too picky about what your vises look like, you're just trying to explore, then you want to engage in this decluttering process. And this is a question of relevance. You have a specific question in mind, and you have to ask, is this part of my viz relevant to answering the question? In other words, does this part of my viz have an impact on the answer to this question? Okay, so in this case, let's say you see that blue line, this blue line at the top is the number of tickets we've received, and the red line is the number that we've processed. So maybe we're just simply asking, are we keeping up with the tickets that we've received? Maybe that's our question. It's very simple. So if we have that question, are we keeping up with the tickets we've received? Then what we have to determine is, if we start with the graph at the top, what elements of this graph, of this viz, are not necessary to answer that question. And so we generate the graph on the bottom, because we're essentially decluttering. We're removing everything that is not necessary and relevant to the question, that does not have an impact on the answer to that question. So if we were in class, this is what I'd do. I'd give you some time, and I'd say, tell me what the differences are between the upper graph and the lower graph. Tell me in what ways were they decluttered. So if you want to pause the video at this point and take some time and identify, you should be able to identify at least 4, but I think you can get 5 things that are different from the graph up above to the graph below. So I'm assuming you've paused it and you've looked at them. And let me just show you what I found. We use purple here. So the first thing you may have noticed, where are we? I need my pen, one sec. Oh, okay, I got it. Okay, the first thing you may have noticed is we have these decimal places. Now notice those decimal places are the same for all our y-axis tick marks. They're always 0.00. So you ask yourself, is that providing any extra information? No, it's not. So we can remove them and be okay with that. Okay, so you can see that's one thing that was removed. Another thing that was removed is we've got this legend down here, and it's just kind of at the bottom of the graph. But we're really trying to emphasize this gap. That's the true story here. Like, if you want to point out where the story is, it's right there. Because our question is, are we keeping up with the tickets that we're receiving? And beginning kind of in May, we start falling behind, and this gap grows and we can never close it. That's the true story here. And so everything that doesn't have to do with that gap can be removed, essentially. And so notice this volume, but in this case, we're kind of not removing something, we're changing it to emphasize. So instead of saying ticket volume received and ticket volume processed, we want to emphasize the gap. So we actually put those labels at the end here because it kind of visually helps emphasize that received is greater than processed. And so it emphasizes this gap. And it's a lot less cluttered than what we see up here in the legend. So that's another thing. So there's one. This is number 2. So you also might have noticed that these months are spelled out. Now, because months are very common, we can recognize a month by the 3-letter abbreviation. In fact, you might even be able to just get away with the first letter, even though some of these letters would repeat. We understand that it'd go January, February, March, April, May, and the 2 M's would be March and May, right? So you could get away with that, but just to emphasizing it, because we don't actually say anything about months in a title or anything, we make it clear that these are months. We don't leave the reader guessing, and we make it clear because everyone's going to recognize 3-letter abbreviations for months. But notice this does 2 things. The first is we don't have to tilt our head sideways to read this, and we can then make them read like we normally would so our head doesn't tilt. But it also removes some extra space here. We're saving space and we're using less ink down here at the bottom. And so it just kind of lines up nicer. So that's number 3. Another thing is you might have noticed these y-axis grid lines. They don't really add anything. So remember, we're trying to emphasize this gap, and so we can do that without these y-axis grid lines. So that's number 4. And you may have also noticed the x-axis tick marks. I usually don't talk about this one. It's pretty minor. They get removed down at the bottom. The other thing that's pretty major is these mark symbols. In Tableau, you're going to learn that these things are called marks by Tableau. We might call them data points. But they take away the square. There's no need to distinguish between the blue with a diamond and the red with a square because the lines are 2 different colors. We use colors to distinguish between received and processed down here. So blue is received, red is processed. And so those tick marks, those squares and diamonds don't add anything to the story of this gap. We don't need them, and so she removes them down here, and we just have a nice clean line, so it doesn't distract from our story. You see, and what she did is she just decluttered. The whole point is to focus on the main story, which is right there. In fact, we'll see later that she's highlighting this gap because the main story is really about going in with a goal. We want to request more employees so that we can catch up and process all the tickets we receive. So decluttering, in fact, decluttering is kind of like free. It's not that hard. So when you turn in your project, if you haven't decluttered, then you're really just kind of like foolishly leaving points on the table because it just takes a little bit of time and thought. It's not hard. There's not a lot of critical thinking. You just remove everything that's not relevant to the main part of your story. So if we were to talk about decluttering in a simple sentence, Edward Tuff says, basically think about you're a cheapskate and you want to save your printer ink. So we want to minimize the ink that it's required to print our visualization. So maximize your white space, minimize your ink. The second principle of a good visualization is it serves a clear purpose. Like, I should be able to look at any single viz you generate, and this is always a trade-off, it's always difficult, and I should be able to spend at most 30 seconds. In fact, you saw with our sevens example that 30 seconds is a long time. I should be able to look at it for 15 seconds and basically say, I know what you're trying to say. I get it. Right? And that takes a lot of work. But sometimes we should just not leave the reader guessing. Notice how right here at the top, she places a very bold and non-beating around the bush title. Please approve the hire of 2 full-time employees. Why? Because we want to backfill those who quit in the past year. So she uses some annotations right here, right in May. She makes it clear that 2 employees quit. She uses some text here to tell part of the story. And then starting in May, we start to see that we get behind. In August, we get this huge gap. And notice, even to emphasize that gap, she starts labeling right where it's important these points with numbers. So if I've got, say, a manager that I'm presenting to, and part of this is knowing your audience. Oh, I know that Manager Joe, he's going to be interested in knowing how big of a gap, and he's going to want to quantify it. So we put the numbers here so he can do a quick subtraction and see what the gap's like. We go from 37, August, looks like we're at 46, right? So you can kind of see that we've gone from 46 to 37, but we're still not closing the gap. So you kind of have to know your audience. But it's very clear what the purpose of this viz is. Because of the title, because of the text, where they explain what happened, and because of the numbers emphasizing the gap. So again, this goes back to what's my question, and how do I best answer that question visually? That's really what it comes down to. And it takes a lot of thought. So that's principle number 2. Make sure your viz serves a clear purpose. Now, principle number 3 is kind of related to the other 2. They aren't mutually exclusive. Because remember, principle number 2 is serving a clear purpose. And part of that is make it easy to understand. So draw the viewer's attention to where you want it. And one way to do that is with color. Notice how the viz on the left here, it's all gray. Your eye doesn't get attracted anywhere. The viz on the right, the color kind of captures our eye. That orange stands out. So then I'd ask you to pause and think, what's that color, what's that orange color emphasizing? Well, if you do a quick look along the bottom here, we can see that this is miles driven per month, and on the X, the Y, it's cost per mile. So she does 2 things here to help our eyes and to focus our attention. She draws a line across the X, in the X orientation, to split the Y space in half. So then we can kind of deduce that these are vehicles. Each data point is a vehicle, and the further it is to the right, the more miles we drive it per month. The further it is up, the more expensive it is, cost per mile. Right? And so what we're highlighting is these cars that tend to be more expensive. So everything above here tends to be more expensive to drive. And so that really helps us kind of divide these vehicles into 2 groups. The cars that are expensive, the cars that are less expensive. and she's drawing attention to the cars that are more expensive. Perhaps she's going into a presentation where they're like, we need some suggestions on how to cut costs. Well, here's one. We do an awful lot of driving, and these cars above this line tend to be more expensive to operate, or these vehicles. Let's look into them and see if we can't eliminate them, right? So, and she did that by focusing the attention. So color is very useful in focusing attention. And there's bright, vibrant colors like orange, red. Then there's cool colors like blue. And orange tends to stand out more. If you just take a look at this color palette, which of these tend to stand out more? The ones on the left or the ones on the right? Well, this red, yellow, orange, maybe green tend to stand out more. They're more warm colors, and blue and lighter shades of green, purple, they're more, sorry, I got that mixed up. Red, orange, yellow, those tend to be more hot colors, and bluish colors, greenish colors tend to be more cool colors. And so you want to use color to your advantage. In fact, if you notice this in the world, advertising uses it all the time. They draw your attention. Good artists know how to use light to draw your attention. Next time you look at a painting, just stop and think, where did my eyes go first? Well, the artist has deliberately used light or colors to draw your attention to a specific area on that painting. And you're going to do the same thing in visualizations to focus attention. Here's another example. You see how on the left everything kind of gets blurred out? It kind of just all blends together. But when we actually make that career development line orange, it stands out, it pops. And then we're kind of pushed to say, well, what's different about career development? Well, let's see, this is employee feedback over time. Well, in career development seems to be the only thing between 2014 and 2015 that is going down in percent favorable. So maybe that's the area we need to work on. You just see how she just told a story with color? Everything else we can kind of be okay. It's either staying, work environment is kind of staying steady, or it's getting better. But career development, that's the area that our employees are saying needs to be more favorable, right? That tells a story with some color, and it focuses your attention on the part that we need to work on. So here's another example, but we're going to talk about focusing attention and layout at the same time. So obviously the orange here focuses our attention, and it's over there in that area of bachelor's degree or more. So if we take a few minutes and we look, this is new marriage rate by education, number of newly married adults per 1,000 marriage eligible adults. We can probably glean that that's the number per 1,000. These tend to be all bachelor's degree. These are some college, high school. But what's less obvious that you probably haven't noticed at this point is what do these individual bars represent? And it's hidden over here on the left. They're years, 2008 to 2012. So then you might be asking, what's the story that we're supposed to be getting out of this graph? Well, obviously they want us to focus on bachelor's degrees, but why? Well, it's not as obvious, but bachelor's degrees tend to be married more often. It's higher than all these others. But if we rearrange the layout, if we presented this with a different type of viz, like this, we then start emphasizing this gap between bachelor's degrees and all other education levels, all other education levels. Plus, we're putting time across the x-axis. And so in general, it kind of pops that over time, fewer people are getting married, but there still remains this major gap between people who have bachelor's degrees and people who have less education. Now, going back to causation does not equal correlation, or correlation does not equal causation, you should be asking, Does that mean that getting more education improves your chances of marriage, or improves your desire to get married? Or does that mean getting married improves your desire to get more education? Well, we can't really make a definitive statement, but it definitely highlights the fact that people with more education tend to be married more often, or vice versa, compared to other groups. And you see how we minimize the... Here, it wasn't as direct at getting to that conclusion, but because we rearranged it to make a line graph, we can then minimize the cognitive effort required to pick up on that story. And that's an important... In fact, that's one of like the great benefits of visualizations, is we can minimize the cognitive effort in helping people understand the important information in the data. In fact, pause and really take that in again. Remember, Einstein said, if you don't understand it enough, if it's not simple enough, then you don't understand it, right? So you've got to know your data, and then because you know your data, you know how to best present it to tell the story that your data is telling. It's an extremely difficult skill to master, and it just takes practice. So another principle, and I'm going to be a stickler on this in your projects, is I want you have to encourage comparison. You remember back when we were defining problems and we were talking about the elevator, and customers were complaining that our elevators are slow? Well, one of the first questions we should have been asking, we should have been saying, slow compared to what? Right? Is it slow compared to the hotel next door? Is it slow compared to Superman? Because it matters, right? And if we don't even have a comparison, then we can't really make an assessment of what slow means. And so visually, we want to encourage comparisons. This is a very busy viz, but it definitely captures comparisons. And what you've got to pay attention to here, let me get the pen and show you where you need to start here. So the first place to start is right here. Understand what these colors mean. Okay, so the maroonish color is the actual values, temperature values for a given day. The gray color represents the normal range, in other words, kind of the average. Okay, and the record high, so the maroon is the actual values in 2013. They're the actual temperatures, actual high and actual low in 2013 on that day. The gray area tends to be kind of like the average range of low-high over many years. Okay? And you can actually see here that looks like although, well, actually we don't know that for sure, so I'm not going to say that. But there's some range of years that gets aggregated in this data. And then the faint yellow range is the record high and record low. So the yellow range represents the range, literally the descriptive statistic called range, of lowest temperature to highest temperature on that day in that month. Okay, so the yellow tells us how cold and how hot it has gotten historically, the coldest and the hottest. The gray tells us on average how cold and how hot it gets at that time of year. And the maroon tells us what the specific high and low was that day in 2003. So knowing that, we've essentially created three comparisons here in this chart that kind of has this hill hump in temperature highs around summertime. So the question is, if we know that, what do these comparisons allow us to conclude? What type of conclusions can you make from this visualization? So again, this would be a good time to pause the video and see what you can identify. See if you can't write down 2 or 3 sentences that capture conclusions. So hopefully you've taken some time and you've captured some conclusions. So let's start with, like, what can we say about 2013? Well, one thing you might have noticed is if you take a look at these actual temperatures in December, they tend to be below the gray band, which is the average band. So we could, sorry, this is January. So we could say something like January was an unusually cold month. It was an unusually cold January in 2003. You see that? We could say the same thing for February. There's a lot of these. We could then say something like the end of March was unusually hot. And look, they've even done some tags, some annotations, so we don't miss some things. So November broke a record for the high, 79 in November. That's pretty warm for New York City. That'd be like a great Macy's Day Parade. What else could we say? I mean, then you can do some more interesting things like August was pretty average. You see what we're doing here? So, we could even say things like December was kind of like there's a lot of variation in temperature in December. Then we could say some really generic things like, well, on average, July and August tend to be warmer than January and December, right? But those don't really take advantage of these comparisons. But those are conclusions we could make. The things that really, the way we can say that end of March was unusually warm is because we have a comparison here where we know what the average temperatures tend to be end of March. Does that make sense? We could even say April, we had kind of a heat stroke in the middle of April. And that's because we know that on average, the temperatures are in that band, right? And we only know that because we've encouraged some comparisons. We've provided comparisons that provide added information. So, just like stock, if I say which stock you want to invest in, well, you're probably going to compare them. If I say, hey, your grade in this class is a 75%, is that good or bad? If you say bad, what you've done, and you don't realize it, is you've compared it to something. You've probably compared it to your past grades, to what you know everyone else tends to get with their GPA. But what if I said the average grade in 415 is a 42%? Just kidding, I'm not that mean. But then you're like, oh, well, 75, man, I performed very well. I'm proud of myself, right? So it's all relative. And so you need to take that principle of comparisons and take advantage of it in visualizations. So if we go back a few slides, you may not have noticed it at this point, when we talked about it, but this average line right there, that's inducing a comparison. It makes us then say these are above average, these are below average. So there's simple ways to induce comparisons. Put in an average line using Tableau. It's easy to do. There's videos that show you how to do it. Even here, we're inducing a comparison, right? So we're emphasizing this gap between those with bachelor's degrees or more education and those without. It allows us to make conclusions that we wouldn't otherwise make. I believe this is the last principle, is if you were in class, I would call on someone to read that purple title. So read that purple title to yourself. And some of you might say, use text wisely. No, that's not what it said. It said, use text. wisely, right? So use it. I'm not saying use text wisely, like don't really use text. Be careful of using text. Use text, but do it wisely. And so make sure it goes back to this decluttering, this relevance. Does the text have an impact on your story, on your question? Is it relevant to the story you're trying to tell? And you see, she said 2 employees quit in May. That's important text. That's important concepts to understand to get the point we're trying to make with this viz. So figure out how to put annotations on your viz and Tableau, and put annotations on there to help guide your reader's thinking. So if your viz tends to feel a little too complicated, where you're like, man, there's no way Dr. Pickard's going to get the gist of this in 15 seconds. Well, then think about, well, how could I put an annotation, a tag, or a text in there to really focus attention and tell the story? So hopefully that makes sense. So I might pull up another slide set that Dr. Zrandon has to talk about these different visualizations. But I would encourage you to go out there and Google like types of visualizations and when to use them. It's really important. I'll just give you, do I actually go into this? Yeah, I don't go into this. If you're talking about whether one variable is correlated with another and they're both continuous variables, which of these visualizations would you want to use? If I want to illustrate whether one variable is correlated with another, which of these would be most effective? Well, if you've got continuous variables, you'd want to use a scatter plot, because your x variable is continuous, your y variable is continuous, and as you plot those 2 points together, each point, those 2 coordinates together, you could start to see if there's a trend. That would be a correlation. Scatter plots are perfect for correlation. Scatter plots are also perfect to show variation. So if you're trying to illustrate risk, and you'll do that by showing variation, a scatter plot would be a good example. If you're just trying to compare averages or sums, you could use, between groups, you could use bar charts. If you're trying to show stuff over time, a line chart is kind of your go-to. Now, these stacked vertical bar charts, I'd encourage you to avoid. And I'll tell you why. Because if the light gray is one group and the dark gray is another group, the problem is that the variation in the values of group 2, the bottom group, force group 1 to start at different y values. And so then your eye has to bounce back and forth. And if I ask you which of these light gray bars is the biggest, you kind of have to visit all of them. You'd be like, oh yeah, probably that one. But you know, it'd be a lot easier if they all started in the same place. If I ask you which of the dark gray bars is the biggest, it's easy to say that one. And so the fact that you start the stacked bar at different locations is really not visually appealing. They have this concept of 100% stack bars, and it ends up being kind of like a pie chart. So it would actually force, you can see them in Tableau, it would fill in, each bar would span the entire range, and then we'd fill it in based on percentage. So it's a little different way to think about things. So if you're going to use stack bars, do 100% stack bars. Same thing goes horizontally. The slope graphs we saw, that was the college education and the number of people married. I don't use waterfall charts a lot. This square area, there's something called a tree graph. It's kind of a bad name, but in Tableau you'll see a tree graph, and as opposed to using pie charts, I'd encourage you to use tree graphs. But if you're just trying to communicate, say your question is, what percentage of people prefer Slurpees over Ices? Well, really, does it require a viz? Maybe you just answer it with a simple text value that looks pretty. Just use like 91%. Okay, so sometimes it actually does make more sense to answer a simple question directly with text. So let's talk about some things to avoid. Be careful not to quote data out of context. So just get your mind around this. If you just presented this graph in the upper left, look, it says Connecticut traffic deaths before 1955 and after 1956. Stricter enforcement by the police against cars exceeding speed limits. So somewhere, say starting 1955, they enforce the speed limit more. Think about the conclusions that you're going to draw if you just show this graph in the upper left. You're going to say, whoa, enforcing the speed limit really reduced the number of deaths. It was a good thing. It's a good thing we enforced the speed limit. But what if we didn't tell the whole story? What if we went back to like 1955, 1954, do you see over here in the upper right, 1953, 1952, and we could see that over the years there was this jigsaw pattern. And right here, let me draw this, one sec. Right here, if this was 1955, we started enforcing speed limits. Well, do you see that you come to a totally different conclusion? You can't conclude that enforcing speed limits reduced traffic deaths, because we also saw a similar reduction 2 years before and a similar reduction 2 years after, right? So we can't make a causal statement that enforcing speed limit reduced traffic deaths. And that's because of the context that the data was in. Well, if we put it in a different context, if over the years we start to see this trend, it's growing, and then we enforce speed limits right here, it's a bad arrow, and we see a drop, and then it continues to drop, right? Then we might ask, well, did enforcing speed limits cause a reduction in traffic deaths in Connecticut? Well, and the answer is really maybe. Because what if there were other elements here? Like, for instance, let's say there was also legislation in 1955 that required snow tires, or you'd get ticketed, right? And that requirement held from this point forward. Well, it could also be snow tires that are reducing traffic deaths. Or let's say they started using ice on the roads. Or let's say they had a bunch of funding come through and they repaired all the roads. Or let's say airbags were invented in 1955. Right? There's all sorts of things that could also cause this to go down. Or even better, like airbags could have been invented in 1956 or 1957, right? And so we can't say that this continued decrease in traffic deaths is solely due to enforcing speed limits. Okay, and then we'd also want to know, did they continue to enforce speed limits? There's all sorts of variation that could have happened here. But let's take another context. If we said this is what traffic deaths were like, and then in 1954, between 1955, we saw an increase, and we're like, oh, let's enforce speed limits, and we saw a decrease. Well, the question is, did enforcing speed limits reduce traffic deaths back down to the normal level? Again, there's lots of things that could have caused this spike, right? Maybe 1954 was just a depressing year and a lot of people drank to drown their sorrows and there were just more drunk driving accidents. Or let's say that a major tire manufacturer had a bad year and there were a lot of faulty tires out on the road, right? Or let's say there was an earthquake. I mean, there's all sorts of things, right? And that changes your interpretation. So if we're going to talk about context that we're looking for, where we are most confident that our speed limit enforcement had an impact, this is what our data would look like. We've got all these years where traffic deaths remain the same, and we've decided, you know what, it's too many, let's enforce speed limits. And we see a drop because we started enforcing speed limits in that year, and then it stays constant. This is where we've got the highest certainty from a critical thinking standpoint that traffic deaths were reduced because we enforced the speed limit. Because there could have been all sorts of things happening, like snow tires, earthquakes, right? Snow tires, I don't know, all sorts of events along this timeline that kind of varied things. But we saw a sustainable decrease in traffic deaths when we enforced speed limits starting here. Okay, so just some critical thinking that you need to engage in with data visualizations. And over here on the right, let's take it even a step further. What if we put Connecticut in the context of other states? So when we're down here and we're like, oh, we had 10.5 traffic deaths in 1954, that's a lot. We got to do something. We'll put it in context in New York, and it's not a lot. When we get to 1955 and we're like, we need to do something, well, one of the first questions we should ask is, well, what makes us believe that this is an abnormally large number of traffic deaths? Well, when we put it in with a comparison with New York, Massachusetts, Rhode Island, states that are close, similar climates, etc., similar traffic, oh yeah, well that looks like we're like ahead of the pack. We probably ought to do something to reduce them. Okay, so you have to be very careful that you provide the entire context in your visualization. If you don't, then you're not an accountant, you're a politician. And who wants to be one of those? All right, so the next thing is you have to be careful not to lie visually with your data. So you can see right here, if you take a look at the size of this mansion, here's the best example, the size of this mansion between Norristown and Warren. Visually, that mansion is almost 2 times the size of Norristown. But look at the dollar amount. It's $213 to $214. Now this is probably cost per capita, I guess. I don't know. So we're kind of lying. We're trying to stretch the truth that shows the amount of money that we're spending in Warren. It really isn't that much more than Norristown, but visually we're trying to make it appear that way. So careful not to lie with the data. Here's another lying, and this really comes down to fuel economy. Here are the years, and here is the fuel mileage, the average fuel efficiency for cars. Notice how this line is like at a greater angle, so it makes this fuel efficiency look much bigger than like 18. But if we were to change the way we displayed it and just did it on a line graph, which would be appropriate, you would actually see that there's actually kind of this decrease in trend in fuel efficiency gains. And so we're kind of like hitting the point of diminishing returns, or we're hitting kind of this ceiling. And so again, be careful how you visualize things, that you're not exaggerating. Here's one. An easy way to lie is to not compare apples to apples. So you might be looking at this thinking, well, where are the apples and oranges here? Well, take a look down here at the bottom. Each of these is a decade, from the first of the year to the last year in the decade, or close. Then when we get to the last one, we've got 1971 to 1974. And we were only using a partial decade. So this 1971 to 1974 is not an equal comparison unit to these other decades. But if you take a look and we finish out the decade, you can actually see that the United States, even though in the first graph it looks like we had this major downturn in Nobel Prizes awarded, towards the end of the decade, we actually caught up and we actually exceeded and broke records. So you got to be careful that you're comparing apples to apples. And then I'm going to let you just play this game and see if you can spot what's wrong with all these visualizations. I'll let you do that on your own time. See if you can jot down 2 or 3 things about each visualization that's wrong. And just in closing, there's a lot of complexities with visualization. Even though we're trying to create something that's simple, there's a lot of factors at play. There's visual factors. We got to clean our data. Our data's got to be accurate. We got to understand our data so that we can present it simply and we can tell the right story. We got to find the story. We got to start the story with a viz and then lead into other conclusions that we can draw from that first viz. There's a lot going on, so it's deceptively complicated. It looks simple, but it takes time. So just be wise. And have fun with the process. I mean, you're going to find that Tableau is difficult to learn and pick up, but you need to start learning how to use visualization tools. So I promise you that the time you invest in Tableau here will pay off in the future. When you learn how to use Tableau, it'll change the way you think about data. And so please don't get frustrated in learning it. And really the fastest way to learn it is to just start diving in and using it. So I made a recommendation of Tableau videos to watch. You'll find those on Blackboard. I recommend you start there. And there is going to be a quiz or a certification on Tableau and a hands-on Tableau assignment that you got to do where, again, you're answering questions and you're presenting visualizations. So that's all. Remember, I won't have office hours this week, but I will be monitoring Piazza to the extent possible. I do want to quickly show you some slides from Dr. Zaranin, for those of you who are still enduring this. I will post these too. And some of the stuff we cover overlaps. She has some good stuff about diverging colors. If you want to try to emphasize the difference between negative 50% and positive 50%, have diverging colors. But let's see, I wanted to show you. She has some really good stuff about best chart practices. So she's going to step through and kind of do what I did on that one slide about what's the best chart to display certain phenomenon. If you want to step through hers, and she gives recommendations about when to use a line chart. So time series is an awesome example when you use a line chart, and that's when time is along the x-axis. And for better or for worse, Tableau really enforces this. It requires that you have a date along the x-axis in order to do a time chart, or a time series, a line chart, sorry. She talks about when to use area charts. She even talks about when to use pie charts and donut charts. I would say there's hardly ever a good reason to use a pie chart. You'd probably want to opt for a donut chart. See, so there's pie chart. That's a donut chart. So it's not, they aren't good for comparing. If you have 2 donut charts or 2 pie charts side by side, it's not good for making comparisons because your eye has to flip back and forth between them. Scatter plots, she talks about those. Bubble charts, these are all charts that you'll see in Tableau. And then she has this really cool interactive question. And answer the question using the chart. And so that'll help you understand the effectiveness of charts. So I'd encourage you to look over those slides too. There's lots of resources out on the web on data visualization. Nicole Mathlick's book is excellent. And you really just kind of dive in and get a feel for it. And again, ask questions on Piazza, have discussions on Piazza. Just a reminder, in the syllabus, I'm looking for 1 question a week and 2 responses, and your 50% participation points will be based on that. So just a reminder about that. Use Piazza, and I'll be monitoring it. So have fun. you're going to get frustrated in this, but when you get frustrated, don't hesitate to come to my office hours, ask in class, just ask questions. Have fun, and we'll see you soon.